So in a previous lecture we were studying about the abstract classes and abstract methods, and I have told you that if you want a situation in which you want to enforce a subclass for the implementation of a particular method which is not being provided the implementation by the superclass, and subclass mandatorily needs to kind of provide an implementation to it, and that is in kind of advantage of that is also in the that is also for the advantage of the subclass to have its complete implementation. The solution here is the abstract type modifier, and when we are going to provide any abstract method within the superclass, it will become the subclass's responsibility, because these methods which are abstract have no implementation specified in the superclass. In fact, no method body is present, and here is a general form in which we are going to use the abstract methods. So the method name and the parameter list is the same. The only difference here is we need to prefix it with the keyword abstract. And any class that contains either one or more abstract method must also be declared abstract. So now let us see this whole concept with the with a program, and here we have a class A, and please notice the keyword abstract before class A. Why this is being given? As I have told you that this is going to have some abstract methods, or at least one of the abstract method which is given in the class A is a void call me. And why this method is abstract? Because of the two reasons. One is it is being prefixed with the modifier type modifier abstract, and another, please notice that it is not having any body here in this class A. So that means this call me method is an abstract method. The class which is going to extend this class A will have to provide an implementation for this call me, and the specific implementation is being provided by the subclass, while this class A is not having any implementation for this method class me, which is an abstract method. And any class which is having at least one or more abstract method is declared as the abstract itself. So the class A is now the abstract class because it is having an abstract method. And then apart from this abstract method, it is having one concrete method also. Concrete method is something which is having a body also, which is actually a kind of a non-abstract, a normal method we can say. So concrete methods are still allowed in the abstract classes. So here this abstract class A is having two methods. One is call me method, which is an abstract method, and another one method which is call me to method, and that call me to method is a concrete, a non-abstract method, and that call me to method is just printing one statement which says this is a concrete method. Now when this class we have a class B which is going to be the subclass of this class A. This class B extends A, and now it is the duty of the class B to provide an implementation to call me. And now here it is going to define, or it is going to put the the method call me as a normal method, because this was actually defined as abstract and it was placed without body in the class A, which is the parent class. So void call me here, and then you can print whatever you want to, or whatever code you want to give inside this call me you can. So here it is just printing system.out.println B's implementation of call me. So now when we are going to use these classes by formation of their objects inside the main function, this is going to be the scenario. We have a class, let's say abstract demo or whatever. Then inside the main function we have created one reference variable and an object of the class B which is named as small b. Now this small b actually is calling b dot call me and b dot call me to, because the function call me is an abstract function, and is class B is providing its own implementation to call me, and the function call me2, which was available inside the class A, is also being kind of inherited by the class B. So now class B is having two functions, one is call me2 and another one is call me, and by printing these two, or by calling these two methods by using the object which is a small b, so b dot call me and b dot call me 2. And what is the kind of, we can say, expectation from the output? The call me is having only one version, which is the version of b, this being an abstract method. Call me 2 is having its version which is available in the parent class. So here both of the functions, which is call me and call me 2, that means a concrete function, a non-abstract function and an abstract function, both are being called here with the help of the object. And please notice here that no objects of class A are declared in this program. And why it is being done? Because also if you are going to try to have an object of class A, this is going to give you an error, because it is not possible to instantiate an abstract class, and the class A was declared as the abstract class because it was having one abstract method. Also class A implements a concrete method. We have seen call me 2, and this situation is actually perfectly acceptable. That is the combination of the concrete methods, which are the non-abstract methods having their own specific implementation or body, along with the abstract method in a particular class, which is going to be extended by another class. And abstract classes can include as many as implementation as they see fit, or depending upon their applications. So here we have seen the concept of the abstract classes, and this abstract classes they cannot be used to instantiate the object, but yes, they can be used to create object references. And this is kind of, we can say, another way to implement runtime polymorphism, which is being done with the use of superclass references. Usage of superclass references we have already seen in our previous lectures. Please recall the program of the class figure, which was extended by the two classes triangle and rectangle. So there we were actually creating the object references, or we can say the superclass references, and also creating a reference to an abstract class so that it can be used to point to a subclass object. That is also a scenario which can be kind of taken here. So let's try to see that with the help of, now we have seen the concept of the abstract class or abstract method, and in the previous lecture we have seen that program of runtime polymorphism of the class figure, which is being extended by the two classes. So here in the next program we are actually going to combine these two concepts, and here it is. So basically we are using abstract methods and classes along with the dynamic method dispatcher. So abstract class figure, why we have written it as abstract class? Because now the area is going to be the abstract method, because we are not going to provide any implementation here in this class figure to the area, because it is not going to make any sense. And here we have two variables, dimension 1 and dimension 2, and then we have constructor which is named as obviously as figure. Value of A is being given to dimension 1, value of B is being given to dimension 2. And now here an abstract method which is abstract double area. Please recall the previous version of the class figure, in which the area was having its own implementation, but it was not making any sense because it was printed as the area is 0 and this figure is undefined or something of that sort. So that means just the superclass figure is not having any meaningful implementation for this method area, unless we define or unless we extend this class figure to the two different classes, which is rectangle and triangle. Now this area or this method area, which is now being defined as abstract, it has now become mandatory for the class rectangle and triangle to define their implementation. Also, one more restriction which is being put on this class figure is now it is not possible to create objects of this class figure, although references can be created. Now, what I am talking about, we will just see through this particular program. So, now here we have a class rectangle which is extending figure, defining its own constructor, calling the superclass constructor by super a comma b, which is a statement which we have seen, or the significance of which we have seen in our previous classes. Then it must provide the implementation for area. So, double area, and now the implementation of area is being provided as inside area for rectangle, and it is returning dimension 1 and multiplied by dimension 2, which is the area of the rectangle. Similarly, the class triangle we have, which is having its own constructor, calling the constructor of the superclass, mandatorily overriding the area for right triangle and giving the implementation of area as system.out.println inside area for triangle, and returning dimension 1 into dimension 2 divided by 2. So, this is what we have seen in our earlier program also. So, nothing new here except the fact that the area is not having any implementation inside the class figure, and inside the class figure it is not only about the specific implementation. This area is not having any body there, because it has been declared as abstract. Also, because of containing an abstract method, the class figure is also abstract here. So, now if we are going to say inside a main method that figure f is equals to new figure 10 comma 10, which we did in our earlier program. Now, this is going to be illegal now, or this is going to, we can say, give us compile time errors. Why? Because figure being the abstract class, it is not possible to instantiate an abstract class. Although we can say figure reference R or figure reference F, till this point just creating an reference for the class is fine, but instantiating a class which is an abstract class is actually illegal. So, we can't do that. So, even if you are going to write figure f is equals to new figure 10 comma 10, it is going to give you an error, and that is why I have given it in the comments portion. Now, we are instantiating class rectangle with the reference named as R and a new rectangle 9 comma 5, triangle T is equals to new triangle 10 comma 8. These are the statements which are kind of we have seen in our previous programs also. Now, what we can do with this class figure at max? So, we can just create a reference variable. No object is to be created. So, we can say figure figure and figure rep, in which we are not creating the object, we are just creating the reference variable. And in this reference variable, based on the concept of dynamic method dispatch, we can always or based on the concept that of a parent class reference can contain an a subclass's object's address. So, figure ref is equals to R, that is perfectly fine, and then we can call figure ref dot area. Then we have figure ref equals to T, and then we can call figure ref dot area. So, the difference which is kind of highlighting here as compared to the previous version of this class figure is now we cannot instantiate the class figure. We can just take one reference variable in which the object address of its subclasses can be stored. That is perfectly fine. So, it is not possible to declare objects of the type figure and all the subclasses of the figure must override area, because now it has become, you know, kind of, we can say, one particular situation, one particular class which is an abstract class, and that figure, you know, that method area is actually your an abstract method. So, not possible to create objects of the type figure. We can only create reference variables, and we have created one reference variable figure ref, which means that it can be used to refer to an object of any class derived from the figure, which are rectangle and triangle here, and it is through the superclass reference variables that the overridden methods are resolved at the runtime. And this is what I was telling you is the concept of dynamic method dispatch we have already which we have already, you know, covered in a previous lecture. So, here in this program, what we have taken, we have started, you know, we have combined the concept of dynamic method dispatch along with the concept of we can say our you know, abstract classes. So, this was actually classes, you know, overriding, then dynamic method dispatch, then abstract classes. We have, you know, connected all the dots, or we have covered all the modules related to our you know, class or method overriding thing here. Now, moving from here, we are going to take our, you know, a new topic, which is about the packages and interfaces. So, please recall that in our, you know, in our initial programs, or in many programs till now, we are not, you know, we are actually not providing any access modifiers to our variables. So, for example, when we are saying double, you know, any dimension 1 or dimension 2 or even class, we are not, you know, at most of the times we are not providing them as public, private or even protected. Why? Because the reason behind that is the concept of packages. So, this concept of packages we are going to begin now. Packages basically, you can say, are container for the classes. Now, why do we need containers for the classes? Because we want to keep our class name as, you know, in different compartments, because packages are stored in a hierarchical manner. I will be showing with the help of the examples, and these packages are actually explicitly imported into new class definitions also. So, basically what are we trying to do here in case of packages? Basically, it is a mechanism to encapsulate a group of classes, sub packages and interfaces. So, within the packages we can have, you know, different classes, within the packages we can have sub packages, and within the packages we can have interfaces. And you know, apart from within these three terminologies, we are familiar with the term classes, but we are not familiar with the term sub packages, and we are not familiar with the term interfaces also. And this is going this is actually we are going to, you know, these are the topics which are going to cover which we are going to cover further. So, basically what is happening, why do we need, you know, packages? Packages, you know, on one hand, packages are actually a mechanism to encapsulation for providing encapsulation, and also the packages are the situation, packages handle the situation when there is a naming conflict. So, for example, we can have, you know, a one common name. Let us say, for example, for a class we have the name class employee, and then that class employee can be available with the, you know, two within the two packages. One is college.staff.ee as in electrical engineering .employee, and another one could be college.staff.csc.employee. So, basically two classes with the same name employee can reside there if their packages are different. If the packages are not different, then it is going to be a problem. So, these packages are going to allow us to have the same name for for classes if the packages are different, and this is going to make the searching, locating the usage of classes, interfaces and annotations easier. So basically how we can understand packages into more detail. So that is what it is. Consider the structure of directory structure which is inside our computer in the file manager. So for example, we have one particular file, let us say file1.txt, and we have file1.txt, that means two files with the same names. Can we have that? Yes, perfectly we can have them if they are located in different folders. So we can have them, but within the same folder we cannot have them. Similar is the situation with packages and classes. If the class is of, let us say, the name employee and it is inside the college.ee.staff, employee can be there, and college.csc.staff employee can also be there. So that means it is going to have this is something which is related to our directory structure, and because of this structure it is helping us in compartmentalization of our classes. Not only the compartmentalization of the classes, it is also providing us the controlled access. How controlled access is provided, and this is what I have started with I have started this lecture with the statement that till this point we have avoided putting access modifiers before many of the class name, because even if we are not going to provide any access specifier, that is going to be a default access specifier with this, and that default access specifier is having the package level access control. So not only the default access modifier which is going to be there if we are not providing it explicitly, the protected access modifier also have the package level access control, and a protected member is accessible by classes in the same package and its subclasses also, because it is protected. So the term, when we say the term protected, it is going to give us the concept of inheritance in our mind, and also a default member, that is without any access specifier, is accessible by classes in the same package only. So here packages can be considered as a way or as a technique to provide the data hiding or to provide the data encapsulation. So that way we can say they are providing the compartmentalization of our classes, they are providing the controlled access also. When we are going to put the related classes into the packages, what we need to do with those packages? We can simply write an import class from the existing package and use it in a program. So basically on the basis of this whole platform, I can say a package is a container which is a group of the related classes, where some of these classes are accessible in an exposed manner and others can be kept for the internal purposes also. And also not only this, these packages are also providing us the facility of the code reuse, because we can reuse existing classes from a particular package as many as time we need it. So for example, we need to have one particular package, and then we will be adding a class to the package. Many classes, not only one but many classes can be added to a package. We will be creating one package, adding many classes to it. It will become like a package directory. Then we can import any of the class or maybe the whole package in our in a different package also. So this is what we can do. So here in order to understand the term package, you can take the analogy from the directory structure. So we can say packages are actually a directory structure for our classes in case of Java. So here in this lecture we have started with the practical implementation of the program of the abstract classes. We have seen how those concept of abstract classes and dynamic method dispatch is going to be used practically, and then we have started with the term packages, and but packages yet many topics or many subtopics are to be considered, which I will be covering in our next lecture. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. Thank you. I will see you in the next lecture. Till then, take care. Goodbye.